Let's see this question. So this is about the closure properties coming to this antisymmetric relations. So whenever you are looking at questions like this, most probably you will be able to answer them using intuition. Otherwise you take some examples and solve it. I'll just show you how to take the examples and prove it right or wrong. See this one. State whether the following is true or false. Every subset of antisymmetric relation is antisymmetric. So what do we mean by subset? They are saying that already a relation is antisymmetric and now they are talking about subset, which means we are not adding any elements, we are removing some of them. Okay, so whenever a relation is antisymmetric, it means that definitely there are no transitive pairs in that, symmetric pairs in that, like x comma y and y comma x. We don't have such pairs. Only such allowed pairs are x comma x, right? So let's say they are already saying that the relation is antisymmetric, which means we have only symmetry. We don't have any symmetric elements. We have only elements of type 1 comma 1 or like this. We don't have 2 comma 1, something like this. Okay, let's say 2 comma 3, something like this. So now if I take a subset of this, subset means they are just deleting some of them. So if you delete some of the elements from an antisymmetric relation, the resulting relation will also happen to be antisymmetric. Only reason why it may not be antisymmetric is if you try to add some elements which will make a symmetric pair, like you have 2 comma 1. If you try to add 1 comma 2, that is when we might get into trouble and the relation may not be antisymmetric. Otherwise, if you are simply removing some of the elements from a relation which is already antisymmetric, which means which does not already have the symmetric pairs, then by removing the elements we will not get a symmetric pair. Therefore, every subset of an antisymmetric relation will also be antisymmetric. You should be careful here because empty set is a subset of everything, right? So if empty set is also an antisymmetric relation, then only we can say that every subset. Okay, in this case empty set also happens to be antisymmetric relation. Got it? Therefore every subset of antisymmetric relation is antisymmetric. So what can you say? The set of all antisymmetric relations are closed under the operation subset. So what does it mean? If you have a set of all antisymmetric relations and if you take any antisymmetric relation, for example R1, and if you try to take a subset of R1, right, and even that relation happens to be antisymmetric, therefore set of all antisymmetric relations are closed under the operation subset. Yes, this is true. Next one is every superset of an antisymmetric relation is antisymmetric. They are talking about superset. So superset need not be antisymmetric. The reason is if you have a antisymmetric relation like this, what is superset? The sets which you get by adding some elements to this, right? Now if you try to add some element to this, let us say like 1 comma 2, then what happens? Because of the presence of 2 comma 1, now by adding 1 comma 2 we are introducing a symmetric pair, which means x comma y and y comma x both belong to R, and by definition if you have any such pair it cannot be antisymmetric. Therefore superset cannot be antisymmetric. So every superset of an antisymmetric relation is antisymmetric is going to be false. Next one, antisymmetric relations are closed under set union. So what they mean to say is if you have an antisymmetric relation R1, let's say, and if you have another antisymmetric relation R2, they are saying that if I take R1 union R2, any such R1 and R2 which are antisymmetric, then the resulting is also antisymmetric. That is what they are trying to say, but it is false. The reason is simple. See this, if R1 is 1 comma 1, 2 comma 1, 2 comma 3, and let us say R2 is, let's say 1 comma 2. Now this is antisymmetric relation and this is antisymmetric relation. By joining them there is a symmetric pair again, x comma y and y comma x. Therefore even though the relations are antisymmetric individually, independently, by merging them the resulting relation may not be antisymmetric because we might introduce the symmetric pairs, and by definition there should not be any symmetric pairs in antisymmetric relation. Therefore antisymmetric relations are closed under set union is false. Next one is antisymmetric relations are closed under set intersection. So one thing is for sure, we already know that, we already have seen that antisymmetric relations are closed under subset operation, and we know that if you have a set R1, then definitely R1 intersection R2 will definitely be a subset of this, isn't it? If you have two relations R1 and R2, I don't care what they are, if R1 is antisymmetric, then R1 intersection R2 will definitely be a subset of it, and we already know that antisymmetric relations are closed under subset operation. So you need not know or worry whether R2 is antisymmetric or not. We need not do that at all, right? Just by knowing that antisymmetric relations are closed under subset operation is enough to solve this. So what is it? Antisymmetric relations are closed under set intersection, which means if I have two antisymmetric relations R1 and R2, they are saying that R1 intersection R2 is also antisymmetric, which is right, because R1 intersection R2 happens to be a subset of R1, which is already antisymmetric relation, and we already have shown that every subset of an antisymmetric relation is antisymmetric. Therefore, by this definition, we can say that this is closed under set intersection. I hope you are getting this, right? So you need not worry whether R2 is antisymmetric or not. So you can even extend this question. Excuse me. You can even extend this question this way. If R1 is antisymmetric relation and R2 is some relation, I don't care whether it is antisymmetric or what type of relation it is, always R1 intersection R2 is antisymmetric. The reason is simple, because R1 intersection R2 is a subset of R1, and we know that every subset of antisymmetric relation is antisymmetric. Got it? Therefore, for any relation R2, R1 intersection R2 is always antisymmetric. See, I am discussing all these properties. Let's say we're taking antisymmetric. Maybe you could even think about all these questions and see what happens if you apply the same kind of questions for reflexive, symmetric, asymmetric, like this. Okay, so even though I'm doing it only for this, it doesn't mean that you should be sticking only to this model. You can take these questions, apply to other relations, and see what happens there. Okay. Next one is set difference. They are talking about set difference. So they are saying that again R1 is antisymmetric and R2 is antisymmetric. Then they are saying that R1 minus R2 is also antisymmetric. It is also true. The reason is R1 minus R2 is again a subset of R1, and R1 is antisymmetric relation. By definition, every subset of antisymmetric relation is antisymmetric, and so this one is going to be antisymmetric. You need not worry about R2 at all. Got it? Under the same grounds, you can say that it is true, right? Or you can even say that, okay, complement. Let's prove complementation now. So now we have shown that under set intersection it is closed, and under set difference it is closed, and so let's see if it is closed under set complementation also. Let's see this. Now can you say that if a relation is antisymmetric, okay, the last question is like this: antisymmetric relations are closed under set complementation, which means if R1 is antisymmetric, they are asking whether R1 complement is antisymmetric or not. So how can we say that R1 complement is antisymmetric or not? You can take an example and see this. Let us say R1 equal to 1 comma 1, and let us assume that these are the relations on a set capital A equal to 1 2 3, something like this. Now what can you say about R1 complement? Definitely R1 complement is going to contain 1 comma 2 and 2 comma 1 and many other order pairs, but I don't care. You can directly see that these two are enough to say that R1 complement is not antisymmetric. Therefore the antisymmetric relations are not closed under set complementation, which means this is false. Are you getting this? So you can take these properties and see whether they are how they behave when you apply them to different types of relations. You can do that as a homework. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is Out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.